Hey everybody, Bill Sky, the Assembly Guy, and what we're going to do in this video is we're going to talk about this thing called table-driven selection. Now, if any of you, and most of you should, but if any of you have seen the switch statement in C, C++, Java, I mean they're everywhere. The switch statement is basically a group of if statements without an if statement that interrogates an integer. So switch statements are absolutely wonderful for menu-driven programs. They're good for checking the status of maybe a Boolean. Anything that requires more than just one if statement and you're dealing with the same amount of data and it's basically simple comparison to a value you're looking for, switch statements are actually very, very useful. And they've been around for years, but they're still a great logical construct that can really help you, especially as I said earlier with menu-driven programs. So I'm going to do a video on x86-64 switch statements as well as ARM, and this is the same introduction for both. I suggest you watch both, but I've got both the x86 and 64 ARM in separate videos. So let's get going with table-driven selection. Okay, so I have an assembler program up here, but just to remind you what a switch statement does. A switch statement, you simply use the word switch, and then you, in parentheses, you specify some variable. I'm going to do this as if it's C++ or C. So I'm going to say char menu selection equals 3. Now, the thing that you're interrogating in a switch statement must be an integer. So what I'm going to do here, now a char is an integer, so that's okay. So I'm going to say switch menu selection. And then within the switch statement, you have a bunch of case statements. So you specify case 1. I'm going to call a function. I'm not going to say call, I'm just going to say function 1. And then you say break. Case 2, you call a function. I'm going to call function 2 here, and then I'm going to break. And then you normally have a default, which means that if it wasn't 1 or 2, if it was something else, I'm going to call a function 3 in this case, and then I'm going to break. And then that's the end of my switch statement. Now, many of you may have learned that it's always a good idea to put this group of statements underneath each case into an open and close curly bracket. I do it that way. It doesn't make the program any larger, but I've seen compilers where if you don't put all those statements in curly brackets, you might have an issue. So anyway, so that is the basis of a switch statement. And basically it's a bunch of if statements. Now for two cases, it's not that big of a deal. You could easily do a bunch of if statements or two if statements. But if you've got a switch statement, or if you've got a value that you're checking like 50 different values, it can be a real problem to have multiple if statements. So switch statements are very useful, and that's a quick little overview of the switch statement. Now let's get on to the assembler implementation. All right, I've got a Linux ARM 64-bit application sitting here. And let's actually get down to the coding. So the first thing you need to do in a case table, in table-driven selection, is you need to create this thing called a case table. Now a case table is a data structure which contains a value you're looking for, you're testing for, and then the address of the function you want to execute when that test is valid. So let's just take a look at it, and it may make a little more sense to you. So I'm going to create a case table, and you can call this anything you want. You might want to mention in the name that it is part of a table-driven selection, and case table is a real industry standard name for that. But I'm just going to call it test case table. And I'm going to be looking for bytes. This is going to be as if the user is typing in a menu option in my program. So I'm going to create a byte, and the byte the first one I'm going to check is for the number 1. So it's kind of like the menu options are 1, 2, 3, 4. Those are horrible menu options, but it's very easy to teach this way. So I'm going to create a byte with a value of 1. That's the value I'm going to be searching for, but then I have to create a D word, an 8-byte word, and that's going to be the address of the function that I'm going to be calling if indeed the result was a 1 that the user typed in. And so we'll do the same thing with 2, and I'll create a double word called function2. Now this might look a little bit weird because normally you don't have variable names or label names to the right of the data definition in ARM, and I'll explain that just as I finish this. So let me go ahead and copy these 2 times. We're going to make this 3 and make this 4. This is going to call function 3, and this is going to call function 4, and I lost an N there. Okay. So that in essence is basically our case table. Now, if I try to build this, I'm going to get a bunch of errors. And the errors are basically, it doesn't know, and I'm not sure why that's not, there it is. It doesn't know what function 1, function 2, function 3, and function 4 are. So let's define those. Those are functions. Those are functions that we're going to call. And I'm going to come down here and I'm going to say function 1, just put a no-op, and a return function 2, no-op, and a return. And let's just copy this 2 more times so I'm not here all day. Okay, so those are the functions that our case table is talking about. So what happens when this program is assembled and linked, what it does is it puts the address of function 1 into this double word, into this 8-byte memory location, because we have the word function 1 there. When it assembles, it'll take the address of the function 2 function, which is down here. It'll take that address and it'll put it in this double word location. Function 3 and function 4, the same thing. Kind of weird, right? So now why are we using a double word in 64-bit? We're using a double word because it's 8 bytes long, and any address in 64-bit is 8 bytes. 8 bytes times 8 bits is 64-bit. So you have to have something the same size as the address that you're putting in there. Now, if it's a 32-bit, you're just going to use a word, right? That's 4 bytes. 4 times 8 is 32 bits. However, if you just put a word in there in a 64-bit application, it'll assemble, but when you run it, it'll die. So you must put a double word in there. All right, so let's save and build this and see if it makes. And look at that, it made just perfectly. So now but that's not the full story here. What we need to do is we're going to be writing a loop in our code section, which is going to be looking at this entry in the case table, then it's going to be looking at this one, then it's going to be looking at that one. So the loop needs to know how big every item is, or every grouping is inside of the case table. So I'm going to create a constant called entry size, and that's going to be equal to the current address minus the address of case table. So entry size in this case will have a value of 8 plus 1 because a byte is 1 in size. So entry size will have a 9. Now you can hard code that into there. But what if you decide to be searching for 2 bytes? Now you've got to go back into your code, into the actual text section of your code, and you really have to modify maybe multiple lines of code. But if you just do it in a constant like this, you don't have to change your code. And that's what's important. You're reducing the possibility of errors. So I'm going to make that. And then now there's one last thing we need to know, is we need to know how many entries are actually in the case table. So I'm going to now I could use the equals like I did up here, but there's another way to do constants, the .equ. So I'm going to say .equ. Again, I'm just doing this just to show you another way of creating constants. Number of entries, current memory location minus the address of case table divided by the entry size constant. So number of entries is going to actually have 4 in it because it's going to take every one of these, add them all up, which will be 32, divide that by 4, and that will be 4. Is that right? my arithmetic might be off a little bit. But the number of entries will tell you how many of these two variables are in this entire case table. It's kind of like an array of structures. So let's go ahead and build that and make it. All right, good. That looks good. Okay, now our code's not doing anything yet. We have the data there. We have the actual data structure there to support the case table. We don't actually have the code. Now, if your case table has 4 items in it, or if it has 5,000 items in it, the amount of code you're going to write is exactly the same in processing the case table. But we do have to define each of the functions. One thing I left out of here, and I'm going to show you how it makes using these constants is so easy. I want to add another menu option, which is the exit. And that's all the code I have to change in my case table. I don't have to change any values because I used constants down here. And let's go ahead and create the exit function. We're going to create that down here. I'm just going to put a no op in there and then just return. Now, why am I using functions? If you remember, in a switch statement, you can put code inside of a switch statement case. The reason is because we don't want my actual logic code to be filled with stuff. Multiple jumps, compares, prints, I mean, all kinds of stuff. So to avoid that, we're going to put them into functions. So let's now start writing our case table or table-driven selection code. Now, the first thing you want to do is I always create a variable called case loop and another variable, or not a variable, a label, and another one called end case loop. Because that is the boundaries of my case loop. I don't have to do it that way, but you don't have to do it that way, but I do it that way. All right. So to get started, the first thing we need to know is we need to know what is the address of the case table. And I'm going to load that into the X1 register. So I'm going to put the address case table into X1. All right. Now the next thing I need to do is I need to put the number of entries in the case table into some counter. I'm going to move that, because it's a constant I use, move number of entries. Okay. Now the autofill didn't, so let's make sure we type that in right. Number of entries. I want to make sure. Now, I could have just built it and seen if it was an error, but all right. Okay, so we've got the address of the case table, because what our loop is going to do is it's going to check this one. If the user typed a 1, it's going to jump and do the function 1. If the user typed a 2, it's going to do function 2, 3, function 3. So we need the address of that case table into some register. In this case, I'm going to put it in X1. Now, I'm also going to be using, I also need to have some kind of a seed, a test value. So I'm going to move into X0 the capital letter X, just because I want to, that's my test value. That's the value that the user typed in. Now, we're not going to write that code in here. I'm going to leave that up to you. But that's the value that the user typed in. And I'm just going to say this is our test value to test the loop. Okay. And we're ready to go. Now we've got our registers loaded. So what I'm going to do in the case loop is I'm going to load a byte into W3 from X1. Now let's talk a little bit about this. What is this doing? So loading a register with a byte, what that's doing is it's going to X1, and since we dereferenced it, what is X1 pointing to? X1 is pointing to the case table. So what are we loading? We're loading this first byte at case table. We're loading it into the W3 register. Now, why are we loading it into the W3 register? Because you can't load a byte into an X register. So I can't load it into the X3 register. I must load it into the W3 register, or into a W1 or a W2. But W1 and W2 are part of X1 and X2, so we really can't put them in there because we're using those. So that's why I'm using W3. Now, whenever I put something into a sub-register, I always like at the beginning of my loop, I'm going to move into x3 0. So I just want to clear out x3 just in case. So we're using W3. Okay, so let's clear that out. Now, again, I always like to build just to make sure I haven't done something silly. All right, everything's looking good. Okay, so let's put our search byte into W3. And now I'm going to compare x0 with x3. Now, why x0? Because x0 contains our test value. X3 will contain, in this case, the first value in our case table, and we want to see if those are equal. If those are equal, then we have a match. So let's see if they're equal. Does the search byte equal our value? Okay. If it doesn't, I always like to use negative logic here because you have less labels and less jumps. I'm going to branch if not equal to next case loop. So I'm going to say no. So let's go to the next entry in the case table. Now we haven't defined next case loop yet. So just for code completion, so I don't forget about that, I'm going to go ahead and do it there. Okay, so now to do this, I need to move to the next entry in the case table. This is the current entry I'm on. I now need to move to this one because now I'm going to test the value 2. Well, how do I do that? How do I move the address to that next value or that next entry? Boom, our entry size constant. Very simple. So to do that, what I'm going to do is I'm going to add to x1. Why x1? Because x1 contains the address of our case table. So I'm going to add to x1 entry size. Move to the next, or I shouldn't say move, I should say point to the next case table entry. All right, so we're going to point to the next one. And now we also have, because we're in a loop, we also have to decrement the counter. And our counter is in x2. So we're going to say subtract x2, comma x2, comma 1. I could have said hashtag 1. I'm just going to say 1. Decrement our loop counter. And now we have to see if the loop counter is at 0. If the loop counter is at 0, then we're done. We've done everything. We've looked at all of the items. So I'm going to compare x2 with 0. Are we done with our loop? And branch if not equal to case loop. So what that's going to do is it's going to branch back up to there and continue the loop. So I'll put a comment here. No. So let's do the loop once again. Now right there, we are at the end of the loop. So what do we want to do at the end of the loop? We want to, well, this is the default condition of a switch statement. At this point, this is the default. So we really want to have a default function. We want it to do something in the default function. We could actually put a bunch of code in here to display on the screen. You typed an invalid menu option. But instead, I'm going to create a function down here. I'm going to call it invalid menu. And I'm going to print something. So let me go up here in my data section, and I'll say invalid selection dot ASCII entered menu option. Let's line things up. Make them nice. Okay, and now we need the length. We need the length of that string. So I'm going to say invalid selection len is equal to dot minus invalid selection. is len. And let's go ahead and print that. Now I'm going to copy this down to my function so I don't forget the name of my variables. And I actually do have some console output code right here at the very beginning of my program. So let's go ahead and put that in there. And then let's put a return. So we're going to say that's equal to invalid selection. The length is going to be is len. And now if the user typed an invalid value, or if we tested an invalid value, we're actually going to display something on the console. And so we're going to call right here, we're going to branch link invalid menu. The user typed something invalid. Our default condition, print an error message. And then there's end case loop, and after we call this function, it will return, it'll fall through, and the program will end. I think that's it. Nope, that's not quite it. That was our next, that was if it wasn't equal. So we did that code. So that was if it wasn't equal. All right, cool. Let's save and build that. Okay. Now, what if it was equal? What do we do if it was equal? We actually found a match. X was found in the case table. So what we're going to do is we're going to load into a register. We're going to use X3 again. I'm going to load the address that's in X1 plus 1. What in the world is that all about? Well, what's in X1? X1 contains the address in the case table we're currently located. And what's that plus 1? Well, we were testing the byte. We now want to take the address of the double word right below that byte, and we want to execute that function. In this case, function 1 if it was a 1, function 2 if it was a 2, function 3 if it was a 3. So we take the address that's in X1, add 1 to it. We're adding 1 because the character we're checking is only 1 byte in size, and put that address into X3. Then we're going to branch link register X3. That's going to execute that function. Then, because we found a match, we're then going to branch end case loop. So we're going to say load the appropriate function address into X3. Execute that function. Leave the case loop. All right, great. So let's see what happens. I put an X in there, and our case table doesn't have a capital X, an uppercase X. So let's run this. I'm just going to run it. All right, great. You entered an invalid menu option. That's awesome. Let's go ahead and put the number 1 in there, which is in our case table. And we're not going to do user entry into here. I'll leave that up to you. We're just doing testing. Okay, so we didn't get an error message, but we also didn't get any kind of validation. So what I'm going to do is I'm going to create a bunch of labels here. And actually, let me go ahead and copy these from some other code I have over here, just so I don't waste a lot of your time you watching me type. And I have an F1 selected, F2 selected, F3 selected. Okay. F1 means you selected option 1, 2, 3, and 4. Awesome. So I'm going to copy those down here to each of these functions, just so I can remember, and I'm going to delete that in just a moment, just so I can delete that. I'm going to copy the print code into each function. And I always like to have a no-op at the beginning, at the end of my functions. And the first string, if they typed in F1, I'm going to put that in there. The F1 length I'm going to put in there. All right, so now I can delete this rogue remind me code. And now I'm just going to copy all of this into each of my functions and change the appropriate label. You're still stuck watching me type a little bit. Can't get away from it. Okay, and we're not going to do the exit function. That's something that you could try out. All right, let's save and build this. All right, great. Okay, so let's go in our code right at the beginning so we can test every one of these. And I really recommend that you test every one. All right, you selected option 1. Make sure we build it. You selected option 2. I'm laughing a bit because I just love it when my code runs the first time, which doesn't happen that often. There's number 3. There's number 4. And let's put in number 5. We know number 5 is invalid, but so let's put in number 5 just to make sure our invalid works. Invalid menu option. Awesome. So that is what they call table-driven selection in assembler language. It's a small little loop that processes all the entries. I mean, think about all the compares and jumps you would have if you had 50 items in a case table, or 50 items you were searching for. When would you ever have that? The United States has 50 states. So if you're processing data that has, uses the states, you have to have 50 compares and jumps. Yuck. However, if you put them all in a case table, first of all, it's kind of self-documenting. Second of all, your code is really small. And you make everything into a function and you compartmentalize things really well. It's just a really good way of doing it. Now, what would I do past this if I were you? Go ahead and debug this. Debug this code, watch it jump around. I'm not going to do that with you today, but watch it jump around, go step by step, have your source code over on the side to make it easier to debugging. The other thing you could do is you could put another label here, and I like to call this entry loop. And I'll come down here and say end entry loop. And right here, you could say, have the user type a value. So instead of having to hard code this value right here, actually have the user type something in, grab that character, put it in X0. So instead of putting a literal, you'll actually, and you'll want to do that down here, put the value entered into X0. So you'll want to do that down there, and then you can actually have a nice, and even print a menu, actually test all that out. All right, so that's our video on table-driven selection, switch statements inside of an assembler language program. I hope you enjoyed it. Debug it, play with it, add some more options to your case table. Actually put all of that into that loop where the user can enter stuff. Great project to do that. I hope to see you at our next video.